Hi, this is Purnima Mahalingam, and you're watching video lecture series on solar and wind energy system. Today, in this video, we are going to discuss about solar thermal systems, particularly deals about the solar thermal power generations, which is a parabolic through the systems. Come, let's go to the video. Here comes to the empathy part. Here what happens is the solar thermal power plant which harnesses the sun's heats. This provides the dissipated power, the global concentrated solar power which CSP markets was valued at 3.5 billion in 2023. Parabolic through technology is the most commercially provided concentrated solar power solutions. So these are the main empathy of this part. Come, let's go into that and we can understand the process. Here comes to the an understanding process. Here, the solar thermal power plant, we are understanding about what it is. Yes, here we are deals about main three part. So one thing is sunlight heats, so which converts direct sunlight into thermal energy. This is distance from PVs. Here we can see sunlight heat. Okay, solar thermal power generations. So then the next one is concentrated technologies. Here we have a concentrated energy focus sunlight onto a receivers. Focus onto an receivers. Here we can see the receivers, which is a plant receiver plant operate at high temperatures at 390 degree to 390 to 565 degrees Celsius for efficient steam. Okay. Here next come the steam to electricity. Here come we have seen the transfer which transfer heat fluids. Here we can see the heat exchanging steam to steam generation to the electricity. Here the stream driven to the turbine for electricity, and finally it is given to the grid. This was the understanding of the solar thermal power plant. Here now you can see here it is the parabolic systems. Here the long U-shaped mirror. We can see the long U-shaped mirror focus directly sunlight. The concentrator into onto an certain receiver tube. Here we can see the receiver contains the heat transfer fluids HTF. This can be synthetic oil or mortared salt. So this can be synthetic oil or mortared salt. That heat transfer fluid is the heat to height with a temperature of about 393 degree Celsius in Fahrenheit, 740 degree Fahrenheit. And this heat fluids that then creates the steam. The steam is very, very important. The steam, this conventional turbine, these stream driven the conventional turbine, then the turbine is connected with the generator, and finally we are getting the electrical output. Here we can see here we can see so many parts. First, we can see the structural designs. We have a parabolic mirror here, parabolic mirror, and we have a receiver tube. We have a receiver tube and heat transferred fluid. We have an heat transferred fluid and a power block. Finally, we have a power block. Here, the power stations is a bare mirror which recognizes certain solar power and site making and includes cutting and turbine generations. Here we can see that the parabolic mirror, this precision forms a high reflective and achieve 92 to 95 percentage reflections. Next, coming to the receiver turbine, the vacuum insulated glass evolved. This features a selective coating that coating ensures 97 percentage of the solar absorption. Next, heat transfer fluid. Here comes to an heat transfer fluid, which is about 400 degrees Celsius. The molten salt can reach about 565 degrees Celsius, which this fluid carries the concentrated heat. So the next comes to includes power blocks. Here includes the conventional steams. It has generated and cooling system. This converted heat energy into the electrical energy. Here next part is Here comes the next part is advantage. Here we have a defined part. Here we have a defined energy storage with a high efficiency, which is an scalability and a grid stability. So energy storage, we have a thermal energy storage with the use of the molten salt, which provide 6 to 18 hours of dissipated powers. That we know that. And then the next one is efficiency. Here we are speaking about the efficiency about 20 to 25 percentage system efficiency, the solar to electrical conversions, and scalability here on the plant of project 50 megawatts to 280 megawatts. Now coming to the grid stability, it's often stable and dissipated powers, unlike interruptions of PV solutions. Here we can see. Now coming to the another part of this, and we have a small analysis of projects. We have so many projects of SEGS plants in USA, which is capacity of 354 megawatts, and its key features is point commercial concentrated solar power. Okay, here we have so many concentrated solar powers and the solar generation stations. Here we have 280 megawatts, first US power plant with 6 hours of storages, and Noor Hawkins 30, which is Marcos, and we have 150 megawatts, which has a capability of 7.5 hours of molten salt storages. And finally, we are coming with Andes, Spain, which is Spain, which is 50 megawatts each, and this is the first commercial plant with molten salt storages. Here we can see what are the challenges, and challenges we have here. It is first one is land usages and water consumptions and cost reductions, and what are the part we have it is cost reductions and innovations, etc. So these are the main process, which is the challenges and future concessions which are here. We have water concessions. We can see here it is cooling systems or water in terms and innovations like dry cooling technologies can offset this, and cost reductions also plays in weight and roles here. Cost reductions, so many things, and innovations. Coming to the innovations part is futures, which is so new technology is with hybrid gap space, which improve dry cooling system technologies. Okay, these things. And finally we are concluding this with part I are concluding so powering a sustainable futures. The parabolic through offer reliable dissipate renewable energy. They are crucial for grid stability. We know that grid stability. They also enabled transients of over 24 into 7 clean power, and contributed in R&Ds and policy supports, which unlocks greater potentials. The concentrated solar power is a project to concentrate about 11% of the global electricity by 2050, as per the research. Finally, here comes your summary. We can summary quickly. The solar thermal power stations, we have seen so many parts of system operation, advantage technologies, we energy storages, thermal efficiency, scalability, and grid stability, etc. So, and comes to the leading projects of we have an SCGS plants in the USA, and solar generation power stations, Marcos, and Spain. These are the leading projects as which related to the concentrated solar powers. Okay. And finally, this is the topic today we are discussed. I hope you understood the video. We'll meet in next video. Thank you so much for watching.